All right, so on number 7, on the 7th, today, it says number 3 through 9 where the homework due date is, because on the assignment you're only doing 3 through 9. I will remind you of that when I hand it to you, but in case I forget to say that, there you go. Okay, so on here, now first of all, you got this, right? And like I said, this isn't going in your ISN. It's for you to keep out separately just so that you're not having to flip back and forth, but it has all the stuff that we've done on it and all the stuff that we're going to do. Lost my train of thought. Oh, I should have put them all together at the beginning. It sounded like a good idea not to do that, but that was not a good idea. So has that, it has the extra tangent half angles on it, all that good kind of stuff. All right, so we are here, and this is going on page 123. We are not doing all of these, not because I just don't want to work them all, although I don't think I would need to anyway. But ones like number 1 and 2, we did not do any identities like that. I know there's some on your pink card that looks similar to that, and we did some value stuff with this, but we're not proving identities with it. There are a ton of different types of identities. We don't have time to do them all, so we're doing like the most important ones. We don't need it to get into all the rest of this stuff right now. So we're going to start with number 3. Okay? And so on number 3, I've got, remember now here we're proving. We're not solving like we've been doing. We're proving. So that means that in the end, I'm not going to get like alpha equals pi 6. I pick the side that looks more complicated. This is my goal, right? And I substitute or change things. Well, it's technically all substitution, I guess. Now, when I substitute something for the cosine of 2 alpha, I have options there. I don't know which the best option might be right now, and I may not even after I get started. I may just have to just pick my favorite. But the denominator, I don't have a choice. There's only one. So I'm going to go ahead and substitute for the sine of 2 alpha. I would substitute 2 sine alpha cosine alpha, and set that equal to tangent alpha, and then figure out what's going on with my numerator, right? So I know in the numerator I'm going to do 1 minus and then something that I'm substituting in for cosine of 2 alpha. And I have 3 choices for that one. Again, sometimes you may not know what the best choice would be, and that's still a matter of opinion. But if you think about what your end result is, I'm trying to get to tangent. And tangent as a quotient is what over what? Sine over cosine. All right, so I'm thinking I'd like to have sine in the numerator. Again, I already have a cosine in the denominator. So if I use the cosine 2 alpha one that just has the sines in it, that would be 1 minus 2 sine squared alpha, right? So we'll try that one since we're trying to go for tangent anyway. So 1 minus 2 sine squared alpha. Right? And again, no matter which one I substitute in, I'm going to get the same answer in the end. I would just do a little bit different work. So in the denominator, that's not going to change right now. I get 2 sine alpha cosine alpha. It's going to be equal to tangent alpha. And then what am I left with in the numerator? 2 sine squared alpha. Is it positive or negative? Positive. Okay. So there's what I've got. So now I can reduce some. I can cancel the 2's out. I can cancel the sine in the denominator with one of the ones in the numerator. So now I have sine alpha over cosine alpha equals tangent alpha. And then what is sine over cosine? Tangent. So tangent alpha equals tangent alpha. I don't know. Because sometimes y'all try to make things harder than they are. And sometimes it's better to just change one thing at a time. I think that some people that are getting stuck on some of these, you go in and you went in there and you changed absolutely everything from the very beginning. Maybe just change a little bit at a time to kind of see where you're going with it. And remember too, you may be going down these roads and you get to a point where you just cannot get anywhere with it. Then instead of sticking with it, abandon it and start over. Because it may just be that maybe you didn't go down the wrong road, but maybe you made some ridiculous mistake that we are all capable of making, and you just don't see it because you keep looking through the same thing. I can walk up to your work and look through it and follow your mistake as well because it looks good to me, and until I sit down and actually write it out and go, oh, that's not what I did. Oh, I see what you did there. And it's something minor that neither one of us caught. So sometimes it's better just to start from scratch, and maybe you end up going down a different road, maybe you don't. All right, so let's look at number 4. I've got tangent of the half angle. Now there's 3 options for the tangent of the half angle. So chances are pretty good that one of them is better than the other to substitute in, but I don't really know which one that would be. And so instead of starting with the left-hand side, I think I'm going to start with the right-hand side and work with that one and maybe see if I can get it to match any of those. So I'm just going to write down tangent of a over 2 equals, now there's no Pythagorean here, nothing squared, no double angles, half angles, so really all I have are reciprocals and quotients. So I'll make cosecant into 1 over sine of a, and then cotangent is what over what? Good, cosine over sine. So cosine of alpha over sine of alpha. And I have a common denominator, and I wasn't even trying to get one just yet. So this gives me tangent of a over 2 equals 1 minus cosine a over sine a. Can I substitute in the numerator and make that sine a? No, because it's not cosine squared, right? So 1 minus cosine a. But I do need to do something because they don't look identical yet. So what can I substitute in for this? Tangent of a over 2. That's right. Some of y'all get stuck because you never actually look at your little identity sheet. You just like stare at me or you stare at your paper. So tangent of a over 2 equals tangent of a over 2, and you're done. That's it. Just because it looks crazy doesn't mean it's difficult. Yeah, the quiz you're doing today is like this, except there's no double angle or half angle. Yes. It's going to be simpler, but let me tell you, the types of mistakes that are happening on this quiz have 0 to do with trig, 0 to do with pre-cal, and 0 to do with the identity sheet. It all has to do with algebra stuff, and y'all making up rules and canceling when you're not allowed to cancel, and I don't know what the heck you're doing, right? So you got to know those things. Yes, sir.
How do you choose like which one to substitute?
Off of that little sheet right there.
Well, like some of them have multiple. How do you
What you mean, like for this one?
Yeah.
Okay, so I waited, and instead of just like starting with that, I put this here, right? And then, I mean, and sometimes you may not have a way to decide. Sometimes it may just be, I don't even know which one's the best. I'm going to pick the one I like the best. And then you'll still be able to get there in the end. But the reason I chose this one is because I'm going for tangent, and tangent is sine over cosine. So I was thinking I needed at least one sine in the numerator. So really I probably just would not have chosen the third one for sure. But one of the first two would at least get me a sine in the numerator. Does that make sense to you? And so since I really just wanted sine in the numerator, that's why I went with that. Now, that logic may not always help you on every single one of them. You may not have enough information to even, like if I just said simplify and it didn't say, you know, this is what I'm going for, then I wouldn't have known, and we just have to see what happens. Does that make sense? But as long as you're doing it correctly and you're not making up any math, things will continue to substitute and you'll eventually get there. Okay, does that help? All right. Let's look at number 6. All right, so the left-hand side definitely looks more complicated. So we're going to start there. And this is my goal. Now, this is sine squared of the half angle. So if you look at the sine of the half angle, that has a square root in it. But since it's squared, what happens to the square root? It cancels out. And there's no options there. It's just that. So that means this is going to give me 1 minus cosine theta over 2. Oh, x. Thank you. Dang it. I've done that every period. Yeah, this should be x. It does, because this is what they're asking you for. If you have a theta in the end, nobody asked you about theta. Does that make sense? Yeah. All right, so now cotangent of the half angle. There's no cotangent on your little identity sheet, right? But what is cotangent the reciprocal of? Tangent. So I can just use the reciprocal of these tangent ones. So now I want you to think without speaking, because you've got 3 options here. If I'm going to use the reciprocal of one of these tangents of the half angles, look at what we have and think about which one might be the most helpful. Don't say anything. Let everybody just think about it. And again, it is a matter of opinion, but I'll kind of tell you what your opinion should be. I'm just kidding. Okay. All right, so you've got 3 down there, right? Which one do you think for sure you don't want to use? The first one with the square root, because it's not squared, right? So I'm thinking the second or the third, but remember you're using the reciprocal. So what do you think, 2 or 3? Okay, it's a matter of opinion, right? So tell me, when you choose, those of you that are saying 3, why 3? Because it gives you a difference of squares, so that's good that you recognize that, right? Those of you that said 2, why? Because it'll cancel out. Now again, we'll get to the same answer in the end, but because I'm using the reciprocal, if I use the second one, this is going to give me the sine of x over 1 minus cosine x. And do you see how that'll cancel out? And again, nothing wrong with using the other one. You're just going to have to do a couple of other steps. When you're working these on your own, you don't know that that one's going to give you, you just go with it and it's fine. And other times you'll pick the shorter way, like it just happens that way. And so then this equals 1/2 sine x. So now I can cancel these entire things out right there, right? So this is 1/2 times sine of x. So yep, pretty much done. 1/2 sine of x equals 1/2 sine x, and we're done. See? So nice. But they're like little, again, they're just like puzzles, and yes, they'll get ugly at some point, but they'll clean themselves up. That's kind of the whole purpose. So, but sometimes it gets worse before it gets better. All right. On the back, we're going to do number 9, and that's it. And we are not doing number 10. So if you want to use this space, like usually when there's a lot of space, I'll need to like do a column and do a column. I'm just going to go straight down because we can use this space. All right. So I have, of these two sides, I think the right-hand side definitely looks more complicated. So we're going to work with that one, and we're going to leave sine of 2x minus tangent x by itself. Okay, and in the denominator, I'm just going to leave that cotangent of x for a minute. So in the numerator, what do you think I could do with the numerator? Can I substitute anything? You ain't got nothing on this card with a 4th on it, right? What were you going to say, Emmanuel? Nothing? Why'd you raise your hand like that? You're saying like, what's up? You're waving at me? Well, hey. All right. What can we do? What? Difference of squares. Is it difference of, oh, is that what you were going to say? Difference of squares. So this gives me cosine squared x. Very good, very good. Minus sine squared x times cosine squared x plus sine squared x. So it's difference of squares. It's really not that bad, right? I'm going to rewrite the left-hand side, sine of 2x minus tangent x, okay? And I'm still going to leave cotangent in the denominator for right now. Let's just clean up the numerator a little bit. So that cosine squared minus sine squared, does that give me 1? Cosine squared minus sine squared. No, it does not. What could I substitute for that? Cosine of 2 theta or 2x. So this is cosine of 2x. All right, so what about cosine squared plus sine squared? That is 1. And this is multiplication. So this is like times 1, which means it really doesn't even do anything. Yes? Okay. So dividing by cotangent is the same as multiplying by what? Tangent. So I'm going to make this sine of 2x minus tangent x equals cosine of 2x times tangent of x. So my goal is the left-hand side. I have cotangent of 2x. I want sine of 2x. And I can't like divide out my 2's or anything weird like that. But I can substitute something for cosine of 2x. And I've got 3 options there. Whatever they are, all of them have 2 terms. So this tangent's going to get multiplied in or distributed in, right? And in the end, I want minus tangent. So I'm going to need tangent to be multiplied by a negative 1. So which one of these 3 would make the most sense then? The third one. So I'm going to rewrite this sine of 2x minus tangent x equals, and then that third one is 2 cosine squared x minus 1 times tangent x. Everybody with me so far? I'm going to rewrite the left-hand side again. So sine 2x minus tangent x equals, so when I distribute that tangent, I'm going to get 2 cosine squared x tangent x minus tangent x. Yeah, now I'm going to go ahead and write out the left-hand side again. Okay, so I got my minus tangent x in there. That's good. But that first term, somehow I've got to get to sine of 2x. What can I make tangent into? Sine over cosine. So 2 cosine, oh, helps if I write the right letters. Cosine squared x times sine of x over cosine x minus tangent x. All right, so what can I do with that cosine? Cancel. I can cancel this out with 1 in the numerator. So that's going to leave me with 2 cosine x sine x. And what's that? Sine of 2x. So sine 2x minus tangent x equals sine 2x minus tangent x. Yeah, you would have. There's not many other options. I mean, a lot of times there's not a lot of other options, so it's like all you got to do, right? So just figure it out from there. But the more you do this, the better you get at it. The more you do this, the more you know this. And I don't mean that like I'm going to take it away and you're not going to get it, but if you don't know these, at least are familiar with these, then you don't even know to look for what those certain things could be that substituted, right? They're not even going to look familiar to you, for you to feel like, oh, it's on here somewhere. Like they should be familiar enough for you so you know it's on here somewhere and relates to something, and you just got to go find it. Does that make sense? And it gets better and better, but you have to practice it. Like you have to do it. You're not just going to automatically know it. Okay? Questions? All right, I'm going to give you your assignment. I'm going to remind you of which ones to do and which ones to mark off. Okay, so look at the assignment I just gave you. These are the questions that you're doing. Bless you. Which means you can omit numbers 1, 2, and 10. Okay, so just mark off 1, 2, and 10. You are doing 3 through 9. They just use, there's nothing wrong with them. They just use the identities that we haven't done and that we're not going to do. Okay. We good? Awesome.